Hello everyone, welcome to the session on hydraulic circuit design and analysis in module 3 fluid power system, subject code 17ME72. So this is a session in continuation with the previous session dealt on the same topic, but here in today's session we are going to study bit advanced mode of utilization of hydraulic circuits or the components in hydraulic circuit to perform particular operation. So the first among the type is called as sequencing circuit. So as the name itself suggests sequencing, it is the control of sequence of operations which is being targeted in the application. So say for example, if we take one simple example of drilling a hole on one particular workpiece, okay, the first operation will be such that you are going to place the workpiece onto the power vise and thereby you are going to feed the drill bit onto the workpiece so that the drilling operation is performed. Okay, so there are two set of operations here. One is fixation of workpiece to the vise, as well as the second operation is performing the drilling process. Okay, so taking those two one after the other is the sequence what it is being defined, and it has to happen in the same sequence to avoid all sort of disadvantages that may be a resultant after the process is been completed. Okay, so here you can observe two cylinders, okay, in the circuit. Okay, the minimum component like the tank, filter, pump, simple pressure relief valve, direction control valve is quite common in almost all the circuits of fluid power system. Whereas if we go with in particular to sequencing, keep in mind it is one after the other. You have to maintain the sequence 1, 2, 3, 4 as such based on the type of operation. So now let us consider in this particular part, this being the cylinder 1 and this being cylinder 2 here. Okay, so as usual, so when the pump receives power from the electrical motor, it drives the fluid which is present in the tank through the filter, wherein the filter traps the contaminants and thereby it allows the clean fluid into the pump. And here in the pump, the fluid gets converted from low pressure to high pressure, and this high pressure fluid will be directed to direction control valve by passing it through the pressure relief valve. If the pressure of the fluid is exactly equal to the set pressure, then the fluid is allowed to enter into the direction control valve and thereby into the actuator, which are nothing but cylinders or linear actuators. If the pressure is more, the pressure relief valve releases the fluid and thereby resulted in the pressure of the fluid being equal to the set pressure or the required pressure. So here in case of sequencing, we have to understand the processing wherein one set of operation is accountable at one time, wherein it is followed by the next set of operation. So if you observe, we have the direction control valve with 4 ports and 3 position. Okay, so here we are again supposed to start from the leftmost envelope to understand the processing of direction control valve that leads to the sequencing or controlling the sequence of operation in fluid power system. So here what happens, the pressurized fluid from the pump will be made to enter into the cylinder 1. So you can observe here, so here it is the resultant of the cylinder 1 here. So the pressurized fluid at the leftmost envelope, if you observe, so the pressurized fluid is entering into the cylinder 1 such that the extension is being achieved or extension is being performed in cylinder 1. Okay, so once the cylinder 1 performs the extension or once the cylinder 1 completes the extension stroke due to the pressurized fluid which is entering into it, okay, thereby once the entire extension is completed, then the pressurized fluid will be then allowed, observe that line here, then the pressurized fluid will be allowed to enter into the cylinder 2 to a system port wherein it leads to the extension of cylinder 2. Means to say that after the completion of extension stroke in the cylinder 1, then the pressurized fluid will be then allowed to enter into the cylinder 2 that results in the extension of cylinder 2 that leads to the next set of operation to be performed. Okay, so here what happens, the fluid once it has resulted in the extension of cylinder 1, the same fluid will not be considered here for the cylinder 2. Here instead the fresh fluid which is entering into the circuit, thus fresh fluid will be allowed to enter into the cylinder 2 that leads to the extension. Here we do have a presence of pressure relief valve here, so that the pressure of the fluid which is resulting to the actuation of cylinder 2 should be with respect to the set pressure, okay, because each of the sequence of operation needs different amount of pressurized fluid to be transferred to perform different types of or to get different type of output. Hence, so the pressure that is required to actuate or extend in the second cylinder will be set in the pressure relief valve, so that the fluid from the pump will lead to the set of that amount of pressure that leads to the extension in cylinder 2. Now what happens? Now comes the process of retraction. See, since cylinder 2 is now extended, we are supposed to come from the back. That is, means to say that now we have to retract the cylinder 2 followed by the retraction of cylinder 1. This is where sequencing of hydraulic circuits comes into picture. In case of extension, first it was cylinder 1 followed by cylinder 2. In case of retraction, cylinder 2 should be retracted followed by cylinder 1. So now consider the second envelope is center off condition that results in the retainment of position in the actuator that leads to certain application. Moving on to the third envelope, okay, you can observe here there is a flow from pump port to the system port, and there is a flow taking place from system port to the tank port, okay. So you can observe here, so during the third envelope that leads to the retraction in the entire sequencing circuit, first we are targeting the retraction of the actuator 2 or the cylinder 2. So you are going to supply the fluid, okay, to the cylinder 2. Once the cylinder 2 is retracted, then the same fluid will be taken through the pressure relief valve and that will be sent into the cylinder 1. Thereby it results in the retraction of cylinder 1. So this is something regarding pressure, that is a hydraulic sequencing circuit. So you can observe the check valve here which allows the flow of fluid to flow from only one direction, and here you can observe both the check valves here are resultant in the allowing of fluid to flow during the retraction stroke rather than in the extension. So you can observe here, so in the retraction there is allowability of fluid to flow through into the tank here, both here as well. So during retraction the fluid which is present here will be allowed to flow and get into the tank. So this is something regarding hydraulic sequencing circuit. Now comes the concept of synchronizing circuit. See here, the major difference between sequencing and synchronizing is that in case of sequencing, the operations has to be one after the other, whereas in case of synchronizing circuits, it has to be in line. Means to say that both the actuators should operate at a time in case of synchronizing circuits. To go with it, we have two types of connections to be studied. The first one being parallel connection and the next one being series connection. So here, with respect to parallel and series connection, it is only the type of actuator that plays a different role here in case of synchronizing circuit. Okay, so let us take one by one. In case of parallel connection, the cylinder 1 and cylinder 2, okay, should operate parallelly. Means to say that at a time cylinder 1 and cylinder 2 should perform the same type of actuation. If cylinder 1 is extending, cylinder 2 should also extend. If cylinder 1 is retracting, cylinder 2 should also retract. But here there is one particular case. When you have to have the parallel connection of synchronizing circuits to operate, at that particular point of time, both cylinder 1 and cylinder 2 should be identical. Means to say that the profile of the cylinder 1 and cylinder 2 should be same. And along with that, the load or the pressurized fluid which is entering into the actuator 1, that is cylinder 1 and cylinder 2, the same amount of pressurized fluid should also enter into the cylinder 1 and cylinder 2. If the load and the structure of the actuators are identical, then it is feasible for a synchronizing circuit in parallel connection to perform the same set of operations simultaneously. What happens if there is two variations? If there is any variation in the opted cylinder 1 and cylinder 2, the structure or the constructional details at that particular point of time, okay, the flow which is resulting into the actuator will always target the type of load wherein cylinder 1 and cylinder 2 are being considered. Say for example, if cylinder 1 is carrying lesser load than cylinder 2, at that particular point of time, when the cylinders are in synchronous circuit or when it is running in the parallel condition, the cylinder 1 will be actuated first because it is considering less amount of load to be driven. Once it is driven, thereby the pressurized fluid will then operate the load which is at, which is greater than the load which is to be carried by cylinder 2. Okay, so means to say that if cylinder 1 is carrying less amount of load at that particular point of time, so cylinder 1 will be actuated, and once completion of cylinder 1 actuation, then the cylinder 2 will get actuated because the amount of load which is to be lifted by cylinder 2 is greater than cylinder 1. Okay, this is one particular case if there is differences in the load, or if there is anything to say with respect to the pressurized fluid that will have no essence on both the actuators, because the pressurized fluid which is coming from the pump is same pressurized fluid entering into both the actuators here. Only it depends on the type of load. Whereas if you have no changes in the load, no changes in the constructional details of actuator, at that particular point of time in parallel connection, both cylinder 1 and cylinder 2 will perform equally. Okay, so you can observe the same constructional details here. So you have a pump. Once the pump receives the supply from the electrical motor, it drives the fluid from the tank through the filter, wherein the filter traps the contaminants, and thereby the pressurized fluid from the pump enters into the pressure relief valve, and if it is exactly to the set pressure at that particular point of time, the pressurized fluid will enter into the direction control valve, and thereby it is sent into the cylinder 1 and cylinder 2. Here the preferred type of direction control valve is solenoid actuated spring assisted type of valve. Okay, so this is something regarding parallel connection. Moving on to the next type, that is series connection. The only difference between parallel and series is that through the direction control valve, the connection between cylinder 1 and cylinder 2 is different than that of parallel connection. So if you observe here, so from the direction control valve, for the extension of cylinder 1, there is a supply from the pump port to the system port A here. Okay, whereas for the extension of cylinder 2, observe carefully, for the extension of cylinder 2, it is the connection from the system port in the cylinder 1, that is system port B, that leads to the retraction of cylinder 1. From that particular port, there is a connection to the cylinder 2 that leads to the extension of cylinder 2 here. Means to say that the connection from system port 2 will be a supply to the cylinder 2 in the first position, that is due to the extension. And to the retraction of cylinder 2, it is the direction control valve to the system port, or you can take this itself as the system port and divert the flow into the tank, or which supplies the fluid into the retraction that has to happen in cylinder 2 here. Okay, so since we have the connection from cylinder 1 to cylinder 2 which operates in series now, there has to be a condition which is to be satisfied. What is that condition? Is that the area of the cylinder 1, that is towards the piston rod end, should be equal to area of the cylinder in the piston end. Means to say that if you take this particular area into consideration, so if this is the area of piston, and what about this particular side? That particular side will be area of piston minus area of rod, that is AP minus AR. So the AP minus AR is the area of the other portion of the actuator here. So that AP minus AR should be equal to area of piston 2, because the other end of the cylinder 1 is resulting in the extension of cylinder 2. So this should be the condition, or the constructional detail should satisfy when you have the synchronous circuit with series connection. Okay, so moving on with the flow here, again the pump. Okay, till here it remains same. So what happens after the pressurized fluid is been considered post direction control valve? In post direction control valve, what happens? The fluid in the first envelope, if you take, it results in the flow of pressurized fluid into the system port, and simultaneously there is a flow of fluid from the system port into the extended port of the cylinder 2 here. So at the extension of cylinder 1, okay, so the fluid which is present on the other side of the piston will lead into the entry of cylinder 2, and that fluid leads to the extension of cylinder 2 here. Means to say that between these flow lines there will always be a pressurized fluid present inside the flow line. Means to say that once there is extension of cylinder 1 due to the flow of fluid from pump port to the system port, from another port in the cylinder 1 leads to the extension of cylinder 2. Means to say that simultaneously cylinder 1 and cylinder 2 both will be actuated. That is, extension will be achieved simultaneously, but only on one condition, that the area on the other side of piston, that is AP minus AR in the cylinder 1, should be equal to AP of the cylinder 2. Okay, so thereby what happens, the area here is same as the area here, and thereby the pressurized fluid which is present on the other side of piston in cylinder 1 will definitely do have the capacity of pressurizing the piston 2 here, that thereby results in the extension of cylinder 2. So this is about synchronizing circuit of parallel type and series connection. Keep in mind, in case of sequencing circuit it is one after the other, whereas in case of synchronizing circuit it is the simultaneous movement of actuation in the actuator. Now let us study few more circuits that relates to the control of speed in the actuator in case of fluid power system. The first one being meter in circuit and the second being meter out circuit. So here, if you observe the construction of meter in and meter out, you will be having the availability of a flow control valve and the check valve, okay, at the inlet of the actuator that leads to the extension. Whereas in case of meter out condition, you will be having the same arrangement at the exit of the actuator or the other port of the actuator that leads to the retraction. Means to say that you are going to consider or meter the input of the input into the cylinder here in case of meter in, whereas you are going to consider or you are going to meter the discharge of the fluid that leads to the retraction in the meter out circuit, or that comes out of the actuator in meter out circuit. So here if you observe carefully, there is bit change in the notation here. So we have the pump port onto the right side, tank port onto the left side here. So it is basically based on the representation here. Do not confuse with respect to how we were representing the construction at the previous case. So here pump port is towards right and tank port is taken towards the left, hence it has been named here. So here we have two valves, one is flow control valve, another one is check valve. We know flow control valve are considered to control the flow rate of the fluid which is entering into the actuator, whereas the check valve which restricts the flow of fluid only in one of the direction. Okay, so we'll observe the meter in circuit now. Here in meter in circuit, since the presence of flow control valve is at one of the port of the actuator that leads to the extension of the actuator, so we are going to consider the entire flow parameter that leads to the extension of the actuator here. Okay, so what happens, from the pump there will be a pressurized fluid which will be entering into the direction control valve. Here the direction control valve is two position and it consists of 4 ports here, so which is manually actuated, spring assisted. So the pressurized fluid from the pump enters into the direction control valve and it passes on to the movement of the actuation in the actuator like this. Observe the first envelope, there is a flow from pump port to system port A, there is a flow taking place from system port B to tank port T. So since we have in the first position there is a flow resulting from P to A, so P to A will be the flow in this particular direction control valve, and the pressurized fluid through the system port A enters into the actuator that leads to the extension. Before the pressurized fluid is entering into the actuator leading to the extension, the same pressurized fluid is passed through the flow control valve, wherein the pressurized fluid at the controlled flow rate will be allowed to enter into the actuator that leads to the extension, such that the steady and movement of actuator is achieved in the meter in circuit or using the meter in circuit. So it is basically during the extension part of the actuator movement. Now moving on with the meter out condition, the same the assembly is identified at the other end of the actuator. So let us go like this, okay. Along with this, again in case of the movement here, there is a flow of pressurized fluid from the pump into the direction control valve, and here observe in the first position that leads to extension, there is a flow taking place from pump port to the system port A. So P to A, that leads to extension, and we don't have any presence of flow control valve here. Whereas in case of second position, that is during retraction, there is a presence of flow control valve. Means to say that what happens in the second position, when there is a flow taking place from P to system port B, that is when there is a flow taking place that leads to the retraction in the meter out circuit, what happens? The flow of fluid along with the pressure, the controlled flow rate of the fluid is taken into the system, so that leads to the steady flow rate, the steady movement of retraction of the actuator in the circuit. So this is meter out circuit. In case of meter in, you will not find any flow rate control in the retraction. Observe here, from P to B in the retraction of meter in circuit. So there is a flow from pump port to B port. B port is onto the other side. So thereby what happens? Whatever the pressurized fluid which is coming from the pump port into the system port B, that leads to the retraction. You don't have any control on the flow rate of the pressurized fluid that is leading to retraction. Hence it is meter in. You are controlling only the inlet of the fluid that is leading to extension in meter in circuit, whereas in case of meter out circuit, you are going to control the flow of fluid, okay, that leads to the retraction. Okay, that leads to the retraction, and thereby we go with meter in and meter out circuits. Coming to the last two circuits of this particular module, that is bleed off circuit or bypass circuit. Okay, so here the major essence of the circuit you can observe here, there is a bypass valve which results in the presence of flow control valve in the entire circuit. Means to say that here in this circuit there will be no control of flow rate of the fluid entering into the system or going out of the system. That is not leading into the actuation, that is extension or retraction. But here the presence of flow control valve leads in such a fashion that, okay, the fluid which is coming or which is diverted to enter into the tank, that will be controlled using flow control valve. Hence it is called as bleed off or bypass circuit. So the only thing is that they don't have any control over the extension or retraction, but they have the control over the diverted flow of the fluid which is entering into the tank. Okay, so observe here. So there is a pump. Again, the simple pressure relief valve. So the pressurized fluid from the pump will enter into the system here. That leads to extension and retraction here. And during the extension or the retraction here, so whatever fluid, okay, that is coming out of the the actuator during retraction, instead of diverting that completely into the tank, you are going to divert the fluid that is coming during the retraction process through a bypass valve, wherein at a particular flow rate the fluid will be sent out. Means to say that using this you will indirectly control the retraction of actuator in the circuit using bleed off or bypass circuit. Okay. Next being the last one, hydraulic circuit with the presence of accumulator. What is accumulator? We have studied the accumulator as an auxiliary device in the hydraulic circuit which stores the potential energy and acts as a secondary source of energy source whenever the system is required. So here observe the figure. This is the symbolic representation of accumulator in the hydraulic circuit, and the remaining thing goes in the same fashion. So observe here. So from the tank there will be a supply of fluid into the pump. Okay, that pressurized fluid will be passed through the simple pressure relief valve. Thereby, if the pressure relief valve is satisfied with the pressure of the fluid, that is exactly to the set pressure, then that particular pressurized fluid, see here we have a check valve. Okay, So the symbolic representation of check valve suggests there is a supply, there is allowability of flow of fluid from the pump into the direction control valve to actuate the linear actuator or double acting cylinder here. But you don't find anything here, you don't find the allowability of fluid to come out of it in the presence of check valve. Okay, so the allowability of or the free flow direction is shown as per the position of check valve. So observe here what happens when there is a flow taking place into the system here. Okay, so here in the first position there is a supply from pump port to the system port that leads to extension of actuator. Okay, so meanwhile what happens, there will be a flow of fluid which is present on the other side of the piston to get into the tank port. Okay, so in the linear actuation at the first stage there is a movement or the extension of piston due to the fluid which is coming from the pump into the actuator. So thereby what happens, there is an extension. Now you have to target the retraction. Okay, when you have to target the retraction, at that particular point of time what we do is you are going to cut off the supply from the pump. Instead what we do is you are going to supply the energy which is present in the accumulator to be allowed to enter into the other port of the system, such that the energy which is accumulated in the accumulator results in the retraction of the actuator. So results in the movement of piston in the retraction phase. So this is how the utilization of accumulator or the energy which is stored in the accumulator is taken into account in the hydraulic circuit. So this is something regarding hydraulic circuit design and analysis for module 3 fluid power system 17ME 72. Thank you.